So here we're given that the specific volume of water contained in a tank at 200 psi is equal to 1.5 feet cubed per pound mass. So we have P is equal to 200 psi, and the specific volume is 1.5 feet cubed per pound mass. We're using English units here. And then we have to find the state of the water. So if it's a single phase, such as a saturated liquid, saturated vapor, compressed liquid, superheated vapor, or if it's a two-phase mixture, so somewhere in between the saturated region. And we also have to find the temperature in degrees Fahrenheit, as well as the quality if possible. So if it's not a compressed liquid or a superheated vapor, we should be able to find the quality. So to find the state of the water, all you have to do is draw a TV diagram, so a temperature versus specific volume diagram, and the temperature is going to be in degrees Fahrenheit. So we'll have that up on the top on the y-axis, and then along the x will be the specific volume, and that's going to be in feet cubed per pound mass. Next, we just draw our dome here, and we can draw our pressure curve going along it, and that's going to be 200 psi all throughout that curve, and then the horizontal there will correspond to the saturation temperature. On the left side here, you have your compressed liquid region, so anywhere here is a liquid, and anywhere to the right of the dome is going to be a superheated vapor. And then you have your 2 points where the dome crosses the pressure curve. So on the left side is where your saturated liquid region is, and then on the right side is where your saturated vapor region is. So now we can just simply use our properties table. We're going to use table A3E because it has the saturation temperature for 200 psi. So at 200 psi, we have the saturation temperature of 381.86. So that's going to be equal to 381.86, and that's going to be in degrees Fahrenheit. And next we have the saturated liquid specific volume. We can write that in underneath. We'll have 0.01839 for the saturated liquid, and the saturated vapor is going to be 2.289. And of course that would be at the x equals 0, and this would be at the x equals 1. Now notice that we're given 1.5 feet cubed per pound mass, so that would actually be in between the saturated liquid and the saturated vapor region, because 1.5 is between these two numbers here. Therefore, we know we're going to have a two-phase mixture, but to find out what the actual quality is and where exactly we are along this curve here, we know we're going to be somewhere on this flat line. We just don't know where exactly we're going to be. We can use the relationship that specific volume is going to be equal to the saturated liquid's specific volume plus the quality times the difference between the specific volume of a saturated vapor minus the specific volume of a saturated liquid. Now, from simple rearrangement to solve for the quality, we know that x, the quality, is going to be equal to the specific volume minus the saturated liquid specific volume minus the difference here of Vg minus Vf. Now we have all of our numbers here. We can just go ahead and plug them in. So 1.5 minus, and we have our Vf right over here, 0.01839. 0.01839. And from that, we're going to divide by 2.289 minus 0.01839. And this is all in feet cubed per pound mass. So all the units are going to cancel out here. So when you solve for x here, you're going to have x equals 0.653, which would be right about here. So you're right about there. And it's going to be, of course, this is not drawn a scale, and that would be your v, which is going to be your 1.5. Now, because you're along that line here, you can go to your saturated temperature. So we know that at these parameters of 200 psi and 1.5 feet cubed per pound mass, you're going to have your temperature equal to 381.86 degrees Fahrenheit. So you have your quality and your temperature.